Welcome back to this video. This video will see class B FLSM. We saw class C FLSM in the last video. So here we have a network given to us 172.16.0.0 with a default network bits of /16. The requirement is 1000 host, and let's say it's for an airport terminal. Just assume that it's a very big hallway with a lot of gates and they need 1000 IP addresses there. So before we talk about this table here, let's talk about this B, class B, right? How do you know it's class B? By looking at an IP address. You always look at the first octet. First octet is 172, and I hope you know the ranges. 172 is between 128 and 191, right? 172 is between this, so it's class B. Class B range is 128 to 191, so 172 is obviously between that, so it's class B, right? Now you see this /16, right? What is this? This is representing the network bits of this IP address. So what I mean by that is, if I write it down like this, 172.16.0.0, okay, we know that each octet has 8 bits. Under 172 8 bits, under 16 8 bits, right? So /16 means the first two octets are the network part. Okay, last two octet are the host part. Understood? So 172.16, this much is the network part, right? And the last two are the host part. Now this /16 can be written this format: 255, and we are done, right? Because we have just completed the network part. Now the rest are the host, so you just write 0.0, right? And how am I getting this 255? These 8 bits you see here has a value of 128, 64, 32, 16, 8, 4, 2, 1. Each bit has a value. Starting from left, we have 128, 64, 32, 16, 8, 4, 2, 1. And if you add all of them together, you will get 255. This is how you are coming up with this 255 number. Again, 16 has 8 bits, and if you add all the values, again you will get 255. So the first two octets will have 255.255 because they're all ones. 8 bits all ones equals 255. 8 bits all ones equals 255, right? Now the rest are host portion, so simply you have another, even these zeros have 8 zeros. And then let me erase this. I put it here. This zero also has 8 bits, and they are the host portion, right? So we know the first two octets network part, last two octet host part. That's why we say /16, because it represents the network part, the first two octets. Now we'll go to this table. So we need 1000 hosts, right? 1000 is between here, right? 2 to the 9 and 2 to the 10. 512 is obviously not enough. 2 to the 10 is enough. But we lose 2 IP addresses for network ID and broadcast ID, but we still get 1022, which is a lot more than 1000. So we can easily go with this. But we only need 1000 plus 1 for the router interface, 1001. Even then we are getting 1022, so we can easily go with this 2 to the 10. So now we have decided that we are going with 2 to the 10, 1024, which gives us this much. So how are we going to find out the block size, IP addresses per subnet and all that? So next thing we need to look at is 2 to the 10, right? We can straight away tell that from this we are keeping 10 host bits. What I mean by that is, if you write it down like this, 172 16 0 0, right? You have 8 zeros here, you have 8 zeros here, and you have 8 ones. This is already completed the network portion, right? Because they're already filled. Now this 2 to the 10, that means we are keeping 10 zeros. You always start from the right, okay? Because from the left we have already taken all the bits are on, so there is nothing to convert. This much is already network portion, so we have to borrow from the right side. So you always start from the very right, and you're keeping 10 zeros. So this much is 8, right? This much is 8, and then 2 more from here. So this first 2, so this much we are keeping. That means from here we have these 6 bits we can borrow. Okay, now 2 to the 10, remember 32, the magic number, minus 10 will give us our new slash value, which is 22. Slash 22 will be our new slash value for this requirement. So from 16 we are changing to 22. And how? Because this much is 16. We already said this much is 16, right? 8 plus 8 equals 16, right? Now we need to borrow 6 more bits. Remember, we are here, so if you count from here, 17, 18, 19, 20, 21, 22. So this is how we are coming up with 22. Even if you don't minus like this, you know from here this much is slash 16, right? Now plus 1 is 17, plus 2 is 18, plus 3 is 19, plus 4 is 20, plus 5 is 21, plus 6 is 22. So you don't need to minus like this. You can straight away tell what would be the slash value like this also, right? Now what would be the block size then? Remember, all these bits has a value. So the first bit is 128, 64. Let me write it like this so you can see it better. You have 8 bits on the third octet, okay, not the fourth octet, the third octet. Let me write it down like this so you can see better. 8 bits, right? This 8 bits I'm putting like this. Just assume like this, okay? Third octet here, not the fourth octet. Fourth octet we have another 8 bits there. We are not even worried about that. We are only working on the third octet. Why? Because in class B, network portion ends after the second octet slash 16. That's where it ends. From the third octet, we can start borrowing, and the borrowal is happening on the third octet, not on the fourth octet. So this 8 zeros I'm putting right here, and each bit has a value. So the first bit 128, 64, 32, 16, 8, 4, 2, one more 0, and 1. So we know we borrowed 6 bits, right? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. And what's the value above that is 4. So the block size is 4 here. This is how you determine the block size. We can also find this block size from like this, 1024. This is the number, right? We have decided we're going with. So 1024 divided by 256. Another number you can remember along with this 32. It will be helpful. If you divide this 1024 by 256, you'll get 4 also. So there are 2 ways you can come up with this block size. One, simply doing it like this. What are your converted bits? So you're converting the first 6 bits. So 1, 2, 3, 4, 5, 6, right? And what is the value of the last bit converted? The last bit converted is the 6th bit and the value above is 4. So this is the first way, or you can just simply divide 256 from the number you're going with. So this time is 2 to the 10, 1024. So 1024 divided by 256. So if it was 2048, again you divide by 256. So you'll get your block size like that. So it is 4 either way. So now we know the block size, we know the subnet mask in slash value format, but in written format it will be 255, 255. We are done, right? The first two octets, 8 bits 255, 8 bits 255, because each bit has again like 128, 64, 32, 16, 8, 4, 2, 1. If you add all of these, you'll get 255. And then second octet 16, again you have 8 bits 128, 64, 32, 16, 8, 4, 2, 1. If you add all of this, you'll get another 255. This is how you're coming up with this 255.255. Now the host portion. It was the default subnet mask is like this 0.0. This is class B default subnet mask, right? But we know that from the third octet right here, we have now converted some bits. In fact, we have converted 6 bits. So you have to add 128, 64, 32, 16, 8, 4. This will give you 252. Now the third octet is no longer 0. It is 252 dot 252. 255.255.252, and then the last octet here we didn't touch anything, we still have 8 zeros. That means it's just 0. So our new subnet mask is 255.255.252. How 252? Again we borrowed 6 bits from the third octet. Here the borrowal is happening on the third octet, and we borrowed 6 bits, and the value for each bit is first bit 128, second bit 64, third bit 32, fourth bit 16, fifth bit 8, last bit 6 bit 4. So you have to add all of this. 128 plus 64 plus 32 plus 16 plus 8 plus 4 equals 252. That's why you are coming up with this 252. And dot 0, you're just putting 0 here because you haven't done anything on the fourth octet. So you still have all the 8 bits there in the host portion. So this is the new subnet mask. New slash value is slash 22. How 22? We have the new slash value slash 22 because this much is slash 16, right? 8 plus 8 slash 16 plus the 6 we just converted slash 22. 16 plus 6, 16 plus 6, 22. So we are done with our calculation. We have the network ID, broadcast ID, new slash value, and the subnet mask written like this. We can easily work this now. So our network ID is going to be, it's the same as what we have 172.16.0.0, but our new slash value is slash 22. This is what given to us. Now it's changed to slash 22. Broadcast ID. We know that our block size is 4, but we won't be able to use the entire 4 size. So minus 1, 3, right? So our borrowal is happening on the third octet, right? This is where the borrowal happening. So the increment also happens on the third octet. Now 0 plus 3 is 3. So it is going to be 3.255, and the usable IP, what's in between 172 is going to be .16.0.1 until 172.16.3.2. 3.254, right? 0.1 until 3.254. This is a broadcast ID, so we cannot use this as an IP address for the host. So 254 would be the last usable IP. So in this subnet you will get 1024 IP addresses. Minus 2, exactly 1022 you will get. Okay, so if I give you an example, it will go like this. Let me put the subnet mask first. 255.255.252.0. Now the first usable we already know 172.16.0.1, right? And that will go all the way until 172.16.0.255, right? And I cannot go beyond that. I cannot put 256, right? So what happens now? I need to move on to 1 now, right? This 0 will become 1. So now I need to move on to 172.16.1.0, and this is actually a usable IP. This is not a network ID or anything because this falls within this subnet, right? 0.0 until 16.3.255. So this is actually a usable IP. You can provide it to a host, and the system will understand that. It will not reject or anything. But this one is a network ID. We cannot use this as a host, right? This is not a usable IP. It's a network ID, but this will be a usable IP. And this will go again until 172.16.1.255, and again I cannot go beyond 255. What happens then? This one will become 2, 172.16.2.0, and again I'll get 172.16.2.255, right? And again I cannot go beyond 255. So 172.16. This 2 will become 3.0, and it will go until 172.16.3.55, and that's where we need to end, right? 172.16.3.55, 172.16.3.55, and this is the first subnet. From here, first subnet, and each of this will give us around 256. Here you are getting 256, and here also you are getting 256, and 256 plus 256 plus 256 plus 256 is equal to 1024, or 256 times 4 will give you 1024. So we are satisfying our requirement with our first subnet, right? We don't need to go beyond this. The only requirement is 1000 hosts. We can use this first subnet for that. This much IP addresses we can provide, and we can provide it for this airport terminal from 172.16.0.1 first usable IP, and then we can go all the way until 172.16.3.254 will be the last usable IP. This one, not 255, that's a broadcast ID. Okay, so this is how you would design when you get a requirement like this with a class B FLSM. So now you know how to work this. If you have any questions, you can ask me down below. So now we'll see this in the packet tracer. It will be a very simple one because we only have one requirement, right? 1000 hosts. So I just take like 2 to 3 PCs, a switch and a router. That's all we need. And then we'll see how this one in packet tracer. Thank you. Okay, now we'll see this in practical. So let's get some devices, get some PCs. Okay, that's enough. And one switch and a router. Because the requirement is only 1000 hosts, so this should be enough. Let me connect these. Okay, let me blow this up a little bit so we can see better. Okay, now we need to go to this router G000 interface, bring that interface up and provide IP address, global configuration interface G00, now shut IP address 172.16.0.0.0 is our network ID, we cannot use it, so 0.1, and then 255.255.252. Remember, we borrowed 6 bits from the third octet and it's no longer 0.0, it's 252.0. Remember this right here, 128, 64, 32, 16, 8 and 4. If you add all this, you'll get 252. That's why we are getting 252. 1 bit borrowal, 2 bit borrowal, 3 bit borrowal, 4 bit borrowal, 5 bits, 6 bits right here. 6 bits. This is how we are getting this 252. Okay. And then the last octet is still 0. We have 8 zeros remaining. So this is 0 like that. Now what we'll do, we'll configure DHCP so that these devices, they get IP address from the pool, DHCP pool. So IP DHCP, this is the first command. We need to create a pool and provide a pool name. So let's say airport terminal B, okay, and network 172.16.0.0, 255.255.252.0, and default router 172.16.0.1, this same one. Okay, this interface address we have provided here. DNS server, let's say it's somewhere in the network and it is 172.16.0.50. Exit, save, and now these, okay, we'll do one more thing. This time we'll exclude some addresses. How to exclude addresses? We'll say DHCP DHCP excluded address, and we'll start excluding from 172.16.0.2 because 1 is taken here, we have provided here. So from 2 until 172.16.0. let's say 20. Okay, and I'm just doing it to show you how to exclude this DHCP exclude address. And if I want to create a scenario why we are excluding this many addresses, let's say these addresses are reserved for let's say like it's for the CEOs and the supervisors and the manager level, those type. So at the executive levels, from the people who work under them, so we are reserving this many IP addresses for those. And yeah, so from 21 until all the way until 3.254 now available, right? That many are available for the entire airport terminal for the host. So this should get 172.16.0.21, the first usable. So first usable is going to be 172.16.0.21. This PC will get that. So what I need to do, I need to enable this radio button DHCP because it will come like this by default. So you need to enable it like this. Now it should provide this 0.21 and it is 0.21. This should be 22, 22, 23, 23 and 24. Okay, 24. So we have satisfied the requirement for 1,000 hosts at airport terminal. This is how you would do it. We have seen how to calculate everything here, and now we have satisfied the entire requirement using just one subnet only, because this 1,000 hosts will come from this 172.16.0.0 all the way until 172.16.3.255, and this one subnet alone will give you 1024 minus 2 because one will go for network ID and one will go for broadcast ID. You will still get 1022 within this subnet, right? Within this subnet you will get 1022 valuable hosts. So hope it helps somewhat. If you have any question, you can ask me down below. Other than that, we'll see some other concept, perhaps class A FLSM, the next video. Until then, If these videos are helping you in any ways, please give me a thumbs up. Other than that, I'll see you in the next video. Until then, stay tuned. Thank you and good day.